Good morning, everyone, and welcome to this webinar. Today, we will be covering our latest addition to the portfolio, Turbidity Expert, which was launched earlier in the year, January, and now it's 6 months after launch. So, this will be an update where we are and covering the benefits of the products. My name is Shora, and I'm joined with my colleague here, Antonio, who leads the research and development for our chemistry function. And together we will be running this session today. The session will last around 25-30 minutes. There will be a question and answers in the end. You can use the chat function on the top to drop in any questions you have, and we can pick up in the end. This session will also be recorded so you can view the recording after the session. And finally, I would like to thank everyone for being here today. We have got a variety of audiences joining from various parts of the globe, including Middle East, Nepal, Pakistan, and in the west side from Chile as well. So appreciate you being here today and look forward to it. So I'll start with the agenda, what we're going to be covering today. We'll start with why turbidity, what is turbidity, and then we're going to run through the instrument itself, Turbidity Expert, the capabilities of it when it comes to testing your turbidity in water. Then I'll hand over to Antonio, who will talk about the best practices, the science behind the instrument, and making sure you get the best out of your operations. And some of the upcoming updates as well will be covered in this session. So firstly, what is turbidity? It is the cloudiness or the haziness of the water sample. As you can see with the picture on the right, you have increasing levels of turbidity as you move from left to right. So on the left most you have 1 NTU, which is the measurement of the units of turbidity, nephelometric turbidity units. And on the far end you have high values like 400, 500 NTUs. So that's the whole spectrum of the levels you find across in various sources of water. And it is really crucial because it tells you the contamination in water, whether there are suspended solids which could be impacting the quality of your water. And also it's a regulated parameter in many of the application, hence really crucial. It's monitored regularly. Now we get some questions around the variety of species that you have linked to turbidity. So there are two other parameters which comes when people are referring to the testing. So it's total suspended solids and total dissolved solids and how they differ against turbidity. So the total suspended solids is basically when you filter the water sample through a very fine micron filter. All the solids that remain on the top, which are greater than 2 microns, that will be deposited on the filter, and then the filter is heated in oven, and whatever residue remains is these suspended solids. So it's measured by the weight of the solids per liter. Compare this to turbidity, which is an optical measurement. So in turbidity, what you're measuring is light passed through the water sample, and the suspended particles are scattering the light at 90 degrees. This principle is called nephelometry. Whereas in total suspended solid, you are actually measuring the weight of those particles. So they are correlated because if one increases, the other starts to increase. However, they do also depend on the particle size, which means you may have water samples with the same level of suspended solids, but they would have different levels of turbidity just because the particle size that is scattering the light is different. The third parameter we have is the total dissolved solids, which is different than these two other parameters in the way that when you have passed the water samples through the filter, whatever passes through the filter is the dissolved solid. So these are particles which are less than 2 microns, and these are the dissolved ions. You measure them electrochemically or using the electrical conductivity meter. So I wanted to highlight the difference here because there are many devices which correlate, but we want to create the awareness that you are measuring three different parameters and you require three different techniques to measure these. So while total suspended solid is a lab-based test, turbidity is a field-based test where you use the optical channel to measure the scattering of light. For this session today, we'll be focusing our discussion on turbidity. And I will introduce you to the instrument, Turbidity Expert. For those who are seeing it for the first time, it's a portable instrument which is out. It can be used in the field to test turbidity of the water sample. It can be used in the back of a van or kept on a table. It's IP67 waterproof, designed to be used by operators with no specialized training. So you have the on-screen instructions coming to guide you the best practices as well. The kit, as you can see in the background, it comes with a set of check standards and all the related accessories that you would need to do the turbidity testing. Some of the people on the call, they are already using the instrument, so feel free to drop in any comments or what you have seen so far. So it's been out in the market for 6 months. I would like to highlight the different applications where turbidity is being measured. It's including but not limited to drinking water, the environmental testing, effluent monitoring, but also various industrial processes and food and beverage and aquaculture as well. We also see some of the swimming pools. There are regulations which drive the testing of turbidity in pools and recreational water applications. So depending on the regulation you are in, the application you are in, you have various levels of turbidity. However, one thing we see the challenges when it comes to testing out turbidity in the field. We have seen the downtime, especially when it's used in the harsh environment. So a new instrument, when it leaves the factory, it's highly accurate, but after long periods of use, as you can see with the lens on the right, some of the instruments we see coming back, they have lots of dust particles, and that will obviously impact the readings, as Antonio will cover in the science of the turbidity testing, why keeping it clean is so important. A second area where we see that the instrument is calibrated by the user as well. So there's user calibration. And if it's not done properly, there can be inconsistency in the reading. And we normally see the very low levels, this can happen. So we have made sure when it comes to the new instrument to take care of these challenges, which I'm going to show you how we have tackled through solving some of these key problems. Right. So it's a summary of what you're seeing here is the summary of the various features and benefits that the Turbidity Expert brings. Key one being it has a modern intuitive touchscreen interface, which means you are able to guide the user step by step of how to perform the test, but also the best practices. Antonio will come to later, like how the check standard traceability also works. We have the IP67 and IQ08 rating, so it can survive the harshest of the field conditions. And the focus on the low range that makes sure in the crucial of the application, you have continuity of testing and you can continue to rely on the results. Now, there is a game-changing feature that is on the Turbidity Expert, which is the patent of our instrument as well, which is the replaceable optics. This optics can be taken out in the field itself. And the reason we do this is because if you, after use, you have contamination and you want the uninterrupted testing, you can simply swap it out. So we provide the spare part and you can carry the spare part along with you so that when the instrument is heavily contaminated, all it requires is a screw out and you can put a new optics in. which means you don't have to send back for return in case of unexpected interruptions. There is a previous webinar we did 2 months ago where Lauren demonstrated how the optics come out. So you can always refer back to the session of like the procedure to take the optics out. So we covered the challenges that normally customers face in turbidity testing, and then we discussed the features and the benefits of the instrument, some of the advancements we have made. I wanted to introduce you to a new feature that will be live in the coming months, later end of the year, which will be the geotagging of your results, which means you can add the GPS coordinates to your turbidity results. What this means is, as you can see here on the example, we did a turbidity test and we got the results. I took out my phone, I scanned the QR code on the instrument itself, and within a matter of seconds, the data was live on the cloud, as you can see here, and you had the coordinates of where the testing was done. Plus, also you have the picture of the site location, which means you can have a foolproof, traceable set of data of not only what the testing was done, but where it was done and what site was used. And obviously, you can set the upper and lower limits, so you can set the pass-fail limits to see the overall trend in time and see where the failures are or the hotspots are. So we are really excited to bring this update to the market, and we will keep you posted regarding the progress. It will be simply a firmware update to your existing instrument if you have got already, and this feature will be live. Now, before I hand over to Antonio, I wanted to finally share one of examples which I'm really proud of, how Turbidity Expert supported one of our key customers in helping the water supply across a region. So a few months back, there was an incident in north part of Wales which caused disruption to water supply because of a pipe burst. Now, this was an unexpected issue, and then the team was working day and night to fix the issue and bring the water supply back. However, when you're repairing and bringing the water supply back of the disruption, the sediments in the water, they increase your turbidity and the sediments will start to flow through your pipes. So what was really crucial is to make sure the sediments are flushed away from the water supply network. So the flushing activity was carried out until the turbidity was brought back in the drinking water range, which was shown to the regulators. And that's when, within a matter of 2 to 3 days, all the homes, they were having the water supply reconnected. So we have got amazing feedback from the inspectors who were going around the county and checking the water quality. They really appreciated the usability of the instrument, how simple it was used, and they could rely on the results. So we are really proud of the work that Welsh Water has done, and we could be part of that. I'll stop it right there and I'll pass over to my colleague Antonio, who will talk through the science of turbidity testing. He'll talk through the best practices. But as we go through, feel free to drop in your questions, any questions you have, and we'll pick through in the end. Antonio, over to you.
Hi guys. I wanted to, a video, an image tells more than a lot of words, but we have a video that actually shows how the instrument works. So as Sauria mentioned before, nephelometry is measure the turbidity through light that is shined through the sample. And as you see in this video, what happens in the instrument is that you apply your shine light into your sample, as we can see in here, and we are zooming into the particles that are in the sample, okay? And as the light hits those particles, they're gonna scatter, that light scatters in all directions. Now what we are doing is measure the light exactly at 90 degrees. Now what is very important here is that the instrument is able to remove all the interference from all the light that is scattered in all directions, and you only measure light scattered at exactly 90 degrees. That makes your measurement very reliable and very reproducible. If you have an instrument that is not well designed, you're going to have a lot of interference from all the scattered light, and that's why you see results that are not reproducible, and depending on the sample and the composition of the sample, you will see differences there. So that's a very quick video, but it actually shows very well, how the technique works of nephelometry. If you have any questions, please just drop them in there. But I guess a lot of you are quite well aware of how nephelometry works and turbidity works. Can you move to the next slide, Saria?
Yeah.
So we supply standards, calibration standards with the instruments. This is something that we only do for turbidity, and it's because the instruments can drift just because of contamination. Also, regulatory bodies, they always want you to check that the instrument is calibrated before you perform any measurements. What we supply is a certificate like that one. We measure every single standard when we manufacture them here, and we can guarantee that those are the values of turbidity of that standard. And then we give you a tolerance that will, give you some certainty into the measurement that you are doing. What is interesting is that we have introduced a code that you see at the bottom of that certificate. So it's a combination of letters and symbols and numbers that you enter in the instrument, and then that means that certificate, the certificate number, the expiry date, and the values of those standards are saved into the instrument. So when you read your standards to check your instrument, you don't have to compare against the certificate to know if the calibration is passed or not. The instrument compares the values itself, and it will give you a pass. And it will record every time you do a check of the instrument, so that you have traceability there of how many times you have checked the calibration, how many days you have checked it. Every single time you have do the check is saved in the log on the instrument. So it's a very nice feature. This is from feedback of customers that, have been doing this and they wanted to simplify the process. Did I miss anything, Saria?
Oh, perfect, spot on.
Yeah, okay. One thing that we are working in introducing in this instrument is a solid check standard. So making turbidity standards at low turbidity is very difficult, okay? Because we are looking at samples that have no imperfections, so the glass has to be perfect. The liquid contains 0 particles, and then scratches in the glassware after use, contamination from fingerprints or anything like that is going to introduce a change to the standard. So if you think that your standard should be 1 NTU, but it's actually 1.1 because of contamination or drift in the standard, if you use that to calibrate your instrument, you're introducing a big error into it. So as Sari has made into this slide, if you are introducing an error of 0.1 at 1%, that is a 10%. But if you do it at 20, if you have an error of 0.1 NTU at 20 NTU, it's only a 0.5% error. That's why we have changed the calibration of our instrument. We don't let customers to use low turbidity standards to calibrate their instruments. They only use to check. We make sure that that is correct when we send you the instrument from here. And what we want is you check the instrument. Now, if you find that your instrument has drifted and the calibration and the bottom end does not pass, your solution is there, because you can just replace the optical pot and you have a totally fresh instrument with no contamination or anything like that. That is the advantage of this instrument. And the use of solid standards is on trial at the moment. We have ordered a few prototypes to give to more water companies for them to check, but everybody loves it because you don't have bubbles. It's a much more robust standard that you just put in the instrument, read, and it monitors that the calibration has not changed. We have tested them here now for a few months, and they're very, very consistent. And we're gonna produce some prototypes that already being ordered to give some water companies, and then we hope to launch it in a few months.
And if you are one of the users who are testing turbidity at very, very low ranges, less than 1 NTU, and you are looking for the standards, please reach out to us and our sales team, your respective account manager, and we can discuss the potential for including you in the trials. We appreciate all the feedback that we get through the trials because it helps us continuously improve.
Absolutely. Now, best practices. With measuring turbidity is totally different from all our other products. In other photometry products, we always have a reagent, and here there is no reagent. What you are measuring is your sample neat. Now, when you're looking at 1 NTU, I mean, a lot of you probably already do it, but less than 1 NTU is not visible to the eye. It's a sample that you will just look against the light and you are not able to see any particles. Yet the instrument will still detect that there is something there. That is how accurate has to be your measurement. Now, if your cuvette, your cell is not clean, if you have not well alignment of the sample because the lid is not well placed, that is going to affect your read. And you might get a read that is more than 1 NTU very, very easily. That is why, using only clean tubes, rinse with the sample before use is very important. And you just put the cap very well so that will sit perfectly aligned in the instrument. And then you can use silicone oil to reduce that effect of, any small scratches into the glassware. One thing that I notice when visiting customers is that if you leave your vials and you put them back in the case and they were a little bit wet, that water is going to dry and that leaves residues in the glassware in the inside. That, the amount of light that you are trying to measure is so small that any small marks in the glass and things like that is going to affect your reads and you will not have good results. Yeah, sorry, can we move? So bubbles, this is really important and it happens all the time. So it's very easy to form bubbles as you are filling your vial. So the best way to get rid of them is to very slowly rotate the vial and you can look at them against the light and you will notice if there are any bubbles left or not. If you don't do that, you're gonna get very unreliable results. One thing to want to prove if you have bubbles in your sample is that if you measure and then you measure again and the result is changing, isn't it? Because the bubbles might be dissipating while you are doing the measurements. Now you always want to remove all fingerprints and dry it very well because if there are any droplets in the outside, those ones are going to affect the light as it passes through and again, it's going to affect your measurement. And then you want to always put the glassware in the same position. That's why we put a diamond printed on the glass because, your glass, if you rotate your glass, just the minimum variation in the thickness of the glass, they will be affecting, they will be affecting the result. I'm just looking at the question and getting distracted, sorry. But that's why we put a diamond in there so that you always perform the measurement with the vial in the same position and that will make your measurement much more accurate. So I'm going to answer the question,
Yes.
from that process, they are asking if the solid standards are SDBB. So no, SDBB is actually a liquid standard, which is the ones that we supply at the moment. It's just SDBB is only an alternative to the normal standard, which is formacine. No, we are talking of a solid standard. So maybe can you go back to the slide when we have a picture?
Yes. Of course.
So that vial there is actually solid. It's like a block of very, very clear plastic that has been molded to the shape of the vial, and you don't have a liquid inside. So if you don't have a liquid inside, one thing that we notice with the standards is that very small particles of contamination in the inside of the glass over time leach into the liquid and they start to increase the turbidity. You cannot have any of that in here because it's a solid standard that is fixed. See something.
Yeah, and the fact that it's stable, which means that even after you're testing for a couple of months or a year down the line, you can continue to make sure that you are within the specification. So right now we are doing the trials to see like we have got some initial results tell us it's highly like stable, but we are collecting more data to see like the different use cases.
Yeah, exactly.
Any other questions, Antonio?
No, this came through Andrew.
Mhm.
He's passing them through.
Right.
Yeah, I pass that to you, Saurian.
Yeah, thank you. So finally, to conclude, we covered the features and benefits of the instruments, and then Antonio covered the best practices, the science of the instruments, and then uh, finally to conclude that the various benefits that you get out of the instrument is the simple to use, more reliable instrumentation, because you have the low range, the work that Antonio mentioned has been done on stray light and the low range verification. The emphasis on the data management and connectivity through the GPS and the field serviceability of the instrument. So this will make the entire portfolio of the pellet test to be serviceable in the field as well. So our team is like continuously like doing the trade-in, so we can support you with the trade-in plans. You can always reach out to your respective account managers and discuss that, or you can always reach out to our contact points, which I'll share you after the end of presentation. Some final support resources that can help you while you're out there. We have YouTube instructional videos on our Palantis marketing channel, which covers all the do's and don'ts, how to perform the test, and all the basic functionalities of the instrument. On the website itself, you have the user manuals and the guides as well to give you overview of all the various features in the instrument. And of course, we are always happy to guide you when you get stuck. And we have the technical support team reachable by support@palintest.com. So feel free to use the multiple touch points you have in case you need more technical support with your turbidity testing and for other instruments as well. And you had the sales contact email. Should you have inquiry about the new instruments you want to inquire about, feel free to direct your questions over there or to your respective account manager. And I'll stop it there to pick up any other questions as we see come through the chat, and we'll wait 2 more minutes, go through the chat, and then we'll circulate the recording after we finish the webinar. Are there any questions, Antonio, on the chat?
Not that I can see.
Mm-hmm.
I think users cannot, they have to send them through our sales colleagues.
Yes. One of the questions actually, Antonio, which I get asked often is around the stray light. What is it actually, and like what creates stray light?
I mean, a stray light is created by your sample. So the
Uh-huh.
particles, when the light scatters through your sample, when they hit a particle, it just goes all over the place. Um, Now, the design of your instrument, and if maybe you want to show the picture of the optical design, the optical
Yeah,
pot, and we can just talk a little bit about that. But when we
go
have,
ahead.
uh, no, probably I was thinking more, yeah, you stop it there.
Yeah,
You
yeah,
see, it's probably not very clear in the image, but you will be looking at, you see the groups that you have there in the corners. Do
yeah,
you have
yeah,
around the sample, there are some ribs. Those ones are making sure that all that light that is bouncing all over the place
yeah,
um, is is not bouncing back into the sample and into the walls of the instrument and eventually get to the detector. What it's doing is like sort of catching it and stopping it there. That's why you have those little ribs in different positions around the
right.
sample. What you're doing, if you have a stray light in your instrument, it means that some of that light that is bouncing, some of it is reaching your detector and you're reading more light than what you actually want. You're getting higher results than what you will expect.
Makes sense. Thank you. If there are no more
So
questions,
There are
Have
a
you
few
got anything on the
questions. Let
sales
me
function?
see,
Yep.
because Lawrence has written, what will be the expected sell-off of the solid? It will be at least 1 year, but it could be more because they seem very
Uh-huh.
stable, but it will be minimum a year. Now we have some comments from Matt Ramsing, but it's just a comment just saying that the lower range is very interesting to them. Yeah, it works very well on that range of 0.01 to 0.5. And another one asking if the instructions will be in Italian already active on the tool. Do you know that, Saria?
So currently on the instrument, no, we don't have Italian. However, we are always open to add a language. So feel free to raise this either directly to myself or your contact point. In your case, that would be Andrew Earnshaw, who can pick up the inquiry and we can pick up your needs. Yeah.
They're asking
And when it
also
comes to the firmware development, we can always include like the new features. So we really appreciate the feedback. If you have any language request or any other feature request, we have like an active firmware pipeline. So we record that in our roadmap, and come the next update, we can incorporate those in. Yes, Antonio.
I'm just going through the comments and trying to don't miss anything. Lawrence is also asking if the solid standard will be solved separately, but that we have to discuss internally. I have a feeling
Yes.
that the measurement at very low turbidity is specific of drinking water industry. So there might be customers that they don't need to check, they don't need that standard, and I think it will be a separate item. But that is something that we have to discuss with what is the customer needs and with our team internally.
Yes.
Andrew is asking about importance of turbidity measurements in the Czech Republic, which is that a question for Karel? Andrew, can you confirm?
Yes, so we can
Yeah,
always follow back on that when we like let us review the regulations. Usually, this is driven by the regulatory landscape. There are European
sorry.
Union guidelines which are used by many of the countries. So based on that, we can come back to it. In the UK, we have 1 NTU when it leaves the treatment works and 4 NTU when it reaches the taps. However, it does depend on the jurisdiction you are in.
It's really interesting.
Any other questions? If you can read through Antonio through the chat.
Yeah, I don't see anymore. Andrew is typing something is related to the regulation of pool sector in the Czech Republic, which you have commented already. And I think we'll have to discuss separate, isn't it, with
Yes.
yeah, well,
Yeah,
that
we'll reach
seems
out
to be
offline to that
everything.
question.
Mhm. Yeah. If you have any other questions, there's a comment. It will be very interesting to hear from export markets on the benefits of GPS tagging now or after. Yeah, that is a feature that is really interesting and we are not also putting it on the turbimeter. It's going to go in all our photometers and other instruments. And yeah, it obviously, gives you the ability of tagging the location of your analysis and then also putting them in Calintest Connect in our cloud system. I mean, the possibilities are endless, but we're working already with some customers that are using it, to map the drinking water testing in a region. So yeah, this is
Mm,
very, very, very interesting feature.
absolutely. Plus, we see with the portable instrumentation, they are carried across multiple sites, and that's
Yes.
where the GPS adds like a tool in that in that whole set, so that they are out there, they are testing, but then they're also sharing the data with the right people within the organization who can make the decisions about water quality.
And setting it live, is being
Mhm.
reported
Yeah,
straight to the cloud, so it can be monitored right where as the measurement is done. Mhm. I don't
any
see
other
any more
questions in the chat?
questions.
Mhm. Right, so we can stop it there. If you have any other questions, feel free to reach out to the sales contact, and also feel free to refer to this recording. We do have a few more webinars coming in the later part of the year. So stay tuned in and reach out if you have any questions or feedback. Thank you and have a nice day.
Thank you.